What's good, everyone? Today we're going to be going on with the Triton Inference server series. You can think of this video as a direct follow-up to the Conda Python backend that we were talking about and overviewing. And this is probably one of the most useful features within Triton that makes it one of my favorite model serving engines to use or recommend to others. And we'll specifically be talking about ensemble mode today. And for ensembles, I'll get to what they exactly are in a second. But before that, just like usual, just for a little one, theoretically overview how production ML workflows actually look in the real world when you have to serve different kind of multiple ML models that you might be working with that are kind of logically tied together, and how Triton Ensembles kind of simplifies that problem when you do have this kind of workflow of different models that are being orchestrated together for a singular inference unit, basically. So let's get right into it. When we're talking about ML in production, right, oftentimes there's not just one model that gets an input and then you simply have an output. Normally there's some sort of pre-processing done, which might require some sort of Python code, some custom Python code, maybe with some custom dependencies, as we talked about in the Conda Python backend. And then maybe you hit your actual model for inference, but then maybe you might have another model that does another task or something. And then finally you might have a post-processor, right, that basically kind of takes this output and structures it. Because what actually comes out of an ML model often, right, especially these more like regression-based models or things of that sort, is not actually what you want displayed to your end user. So you might have some sort of post-processing with some sort of custom Python code that does some structuring or kind of shaping of the output there, basically. So the main essence here, right, is yes, this is technically one inference request, but in reality, there's multiple moving pieces, and these pieces, right, can be both Python code or various kind of ML models working together. So we have these independent units that kind of compose of this singular workflow that we want to hit, basically. And this can be complicated, right, if we group all of it together into just a single backend or a single container, because we can't really pinpoint where the errors are, where there's maybe any performance bottlenecks, and it's not as clean when you have everything kind of meshed together into a singular container or the most performant. So where Triton Ensembles came in is that they gave us an option where, let's say you have multiple different models or multiple different pieces of code from different backends. So let's say we have our preprocessor on our Python backend, and let's say we have our model, a torch model, on the torch backend or the libtorch backend. I forget the exact naming of it. And then let's say we have a post processor that takes these outputs, and this is also on the Python backend as well. So these are different moving blocks that we want to be able to bring together. Ensembles allows for you to define these different units or steps, and then the order in which you want to orchestrate them. So it can be sequential like it is here, such as A to B to C, or then it can also be A and then maybe B and C happen in parallel, and then you have a final processor or something here in terms of D. So you can kind of define these steps kind of in a bit of a DAG, a DAG to represent your logical inference workflow in terms of what needs to happen, in what order, and what exactly are you looking at. So ensembles, right, it leverages the fact that Triton has multiple different framework supports via the different backends, and via this kind of mode, it lets for you to logically stitch all of these together. And the beauty about this, right, is that you can also specify specific configurations for each unit. So for example, your preprocessor, if you want it running on CPU that you have behind your host or machine that you're hosting all this on, you can allocate it as that. Maybe you want your actual torch model to be running on a GPU, post processor on a CPU. Maybe you want batching enabled for your torch model, right? So each independent kind of unit, you can define your own optimizations, and as a whole as well, you can also define optimizations for the ensemble. So it's really bringing together all these different kind of individual backends that we've learned about and putting it together into a kind of workflow that makes sense when you have a clear ML kind of inference logical use case that needs to happen. So this will still be a single request as we see, but it's neatly decoupled into these different moving parts that makes it easier both for debugging, performance bottlenecks, and any kind of tuning that you're working with as well. So with that being said, let's just hop in directly into our friend SageMaker AI, I'm using that same G54X large that I was using for the Conda Python backend. And in that exact same repo, I have a Triton Ensembles notebook that I'm working with. And this is going to be a little more complicated to set up, right? Just because we have different moving parts. But at the end of the day, the same repository structure and everything kind of stays the same. So our use case, before we get into any of it, I kind of already diagrammed it out, is we're going to have some sort of pre-processing where we're going to be using the Python backend, and we're going to orchestrate this on a CPU. Then I have a Hugging Face inference model, whose model artifacts I brought down, the torch model artifacts, and I'm going to use the PyTorch libtorch backend. You can obviously convert this to Onyx, play around with it whatever way you want, and use that backend potentially. And then that output, I basically want to do some post-processing and output something that makes logical sense to me as an end user. So this is kind of a traditional, maybe simple, but kind of ML kind of use case that you can kind of map to an ensemble. So we have our three components, right? Then we have to think about a directory structure. And this will all map into this HF pipeline directory. So this HF pipeline directory you can kind of think of as our model repository for our ensembles. And we have each of these different parts or individual components that we're defining. So for pre-process, just like we did with the Conda Python backend, I have an idea that, hey, the input is going to be type string, and this is the output that I want back. And then I have my model code in that model.py kind of structure that Triton expects. If you haven't seen the Python backend video yet or the Torch backend video yet, I would get started with those in the series before coming here. Here I'm going to grab a distilled BERT model. We're going to do some sort of text classification or sentiment analysis here, basically. But before that, I want to use the tokenizer to basically tokenize our input text before passing it into our torch model. Because our torch model with pure inference is expecting these tokens rather than a string itself. But it depends on the model too. I think you can maybe play with both depending on the model there. But here I've defined that, and you can see it's the exact same structure as what I had for when I was working with just the vanilla Python backend. The key part here is, once again, remember the names of your input and output, because this is how Triton passes on data from each component. So the input text is what is expected in the model.py, but for the next backend or component that we're going to, this input IDs and attention mask is the output of our first component, but is going to be the input for the second component that needs to be picked up on. And if we come back here, right, our second component we have is our torch classifier. And what you can also do is I've generated the torch artifact here, so you can take this code and dump it here in this one model version directory. I recommend running it. I do have the model.pt by GitLFS already on GitHub, but it might be a little corrupted. I don't recommend going that route. Just run this cell here and plug it into this model1 directory right here to have your model.pt. But essentially all this code here is doing is grabbing that serialized model artifact for us to be able to work with for the torch backend. So if we come to our torch classifier, right, once again, we have a configuration file, and we're expecting that input that we're going to be working with that was the output from our pre-process backend. So that's the input IDs and attention mask after the tokenization happens, basically. And then we're going to output logits, basically, which we can then convert to say, hey, this is positive or negative for sentiment analysis for the number of labels that we have. And if you notice, for this, we're going to be using GPU for the model inference here. So the neat part, once again, about Triton is, for each kind of component, you can select the configuration that you want. So for model inference, traditionally, I'd probably want that on a GPU if it's a heavier model that I'm working with. I think you can run this specific one on a CPU, but you get the idea. Let's say you replace this with maybe VLLM-based model. You're obviously going to want to use a GPU-based instance here rather than a CPU. So you can select the configuration for each moving component, essentially. Now that we have that defined, right, the third component is the post-process, which is very, very similar to how we set up our pre-process, leveraging the same Conda Python backend. We're processing the input that we were getting as output from our torch backend, and then we're going to output a label, which is a string basically about positive or negative for the sentiment in terms of the input text that we have. And once again, I specify type CPU, and then I have my actual model inference code here in terms of what I'm working with. And remember, once again, I said this in the Conda Python backend, when we're parsing for request, it's very important that we label it the same as what's here, and then that's how Triton kind of picks up on these are the input and output specs that we're passing in. Now the new component really that we'll be adding here, right, that brings all this together is our actual ensemble right here. And if we go into the config file, explain the need for a dummy file there in a second, we'll see our original input and output. So our input is going to be the text. That's what we've sent into our pre-process. Our output is going to be the final output from our last component, which was our post-process, right? So if we come here into post-process, our final output's labeled. So here for the input and output of the ensemble, it should be the first input to your first component, and it should be the last output of your last component, basically, that you've defined. And now that we know what should be coming in and coming out of the sequential inference workflow, the final thing that you want to do is enable kind of scheduling of this. So what is the order in which these components need to get executed? So these are the different steps that we define, and we're simply going to be taking those input and output shapes and basically, the names there and mapping it over. So the first one that we want executing is our pre-process model, and remember, it's just map it to the directory name to keep it simple right here, and have that in the config file as well, that name right there. And then we basically say that, we say the model version that we're working with, we specify our inputs that are coming in, and then the outputs that are coming in too. This is our first step that we're basically working with here, this dictionary right here essentially. Then our second step, right, since it's a sequential workflow that we're working with, is our torch classifier. And with our torch classifier, we're once again, the output from the previous step is going to be the input for this, then we're going to get an output here. Same thing happens here with the post process, where this output is passed in as input here basically, and then we finally get a proper output there. So this is basically where the real magic is happening in terms of, hey, orchestrate everything in this manner basically, or this sequence. So if you have a parallel-based workflow, you can do something like that as well. And if you have sequential workflows, which for the most part is what I've worked with here, you can go in that order too. So it's very, very key to kind of understand maybe draw out what your workflow looks like before orchestrating everything. Everything else here will be pretty standard, just like we built a Docker image for our Conda Python backend. That's exactly what we're doing here with this Docker file. We're essentially just installing transformers and torch for our Conda Python backend. Any kind of proprietary packages or dependencies that you have, you can also set up here basically. All we're going to do is do that, and then we're going to build our Docker image itself. So if I open up a terminal here and come here, and we do Docker images right here, we'll see that. Let's make sure we're in the right directory. And then we start up this Docker container, right? We can take this. And also, by the way, if you don't have any kind of custom Conda Python backend or anything that you're working with, you can just use the base image that NVIDIA already provides for Triton Inference Server. But then we're going to start up this container, right? And once again, I'm in a GPU instance because my torch inference, I want to be using a GPU instance type basically. But you can adjust this depending on your use case. So I start up this container, and you'll see that it's going to be picking up on the kind of ensemble workflow, but also all the different moving components and models that we have here. And once this is started up, you should see 4 separate models being ready for the sample. The 3 individual components, pre-process, torch, and post-process, then the ensemble, which brings everything together, basically. And here I'm just going to be sending in HTTP requests, once again using the Triton Python client. You can change this depending on whichever kind of protocol that you want to be working with. Here I'm just going to pass in 3 sample texts. I'm so upset. I'm super happy. Life is great. Should be negative, positive, and positive, right? So if I run inference right here, just rerun this, you'll see negative, positive, positive as what was being passed in there. And you can also see this once again, or capture this with the logs here itself in terms of what's happening. And you can get a better understanding in terms of any performance metrics or load testing you might want to be doing. But yeah, that was mainly what I wanted to talk about today at a high level. I think Triton Ensembles are a very, very powerful feature that kind of help you bring together pretty sophisticated ML workflows into a singular inference unit, while still allowing for you to decouple them to kind of best tune them for performance, and also understand where there might be any errors in your workflow, rather than having a single bulky container with everything where it's kind of hard to understand or debug what's happening essentially. You kind of bring each of these into their own isolated components. What I also always recommend is, I kind of said this in the Python backend video too, I like locally testing my entire workflow end-to-end. So even if you're using a managed service like SageMaker, use Docker on a node like this, whether it's SageMaker Classic Notebook instances or EC2, wherever you have it installed with the machine that you need, and quickly iterate, because you want to be able to fail fast and understand where your bottlenecks or anything is at first. So I always recommend using something like this beforehand, before even taking it to a managed service like SageMaker. But yep, that's mainly what I had for today for the Triton Inference Server backend. I think I'll push out a VLM video as well. You can interface with that too through Triton. we can explain how that works. But at a high level, this is mainly what I had for the series. It's a very powerful model server that you can use for very sophisticated ML use cases. Take it for a spin. Let me know if you have any questions. As always, feel free to leave them down below in the comments. Reach out to me on LinkedIn, Twitter, wherever it is that you're comfortable. Thank you as always for watching. If you enjoyed the video, feel free to leave a like and subscribe, and I'll be back with much more in this space. Thank you, everyone.